Common interview question: rotate array k times, where the array is given with size n and the k steps are given. So we need to rotate this array with k steps, and the final output will look like this. So let's understand how rotation works. So we have given an array with values 1 2 3 4 5 6 7. So each element will shift to the next element in first rotation, to the next, then 2 3 4 5 6, and the 7 will come to the first place. In this is first iteration. In the second iteration, the 7 is shift to the next index, then 1 2 3 4 5, and then 6 will come to the first index. This is the second iteration. And in third iteration, again the 6 will shift to the next index, then 7 1 2 3 4, and then 5 will shift to the first index. And that is our final answer. Check, the expected output is 5 6 7 and 1 2 3 4. But this solution will take the time complexity of O of n into k, where n is the size of an array and k is nothing but the steps. And the space complexity is 1. Let's check another brute force approach for solving this. This is another brute force approach where we create the new array. So this will take the space complexity of O(n). But this is the first index, this is the index n minus 1, and this is the n minus k index. So this is our first array and this is our second array. So when we create the new array, we will copy n minus k to n elements. So that is 5 6 7. And in next step we will copy from 0 to n minus k minus 1. So that is 1 to 4. 5 6 7 and 1 2 3 4. This will take the time complexity of O(n) and the space complexity of O(n) as well. But can we do it in time complexity of O(n) as well as the space complexity of O(1)? Now let's check the optimal solution for rotate array k times, where we have the index here 0, then we have n minus 1, and here is our index n minus k. Okay, so we have first array, that is 0 to n minus k minus 1. So this is k minus 1 element, and second array is 5 to 7, so that is n minus k to n minus 1, and our third array is 0 to n minus 1, n minus 1. So we have these three arrays. So first we will reverse the first array. So we will call reverse method, which will reverse the first array, that is 0 to n minus k minus 1. So in first iteration, our array will look like, after reverse, 4 3 2 1, and the rest of elements will be same. Then our second array, n minus k to n minus 1, so we will reverse this array. So the next iteration, the array will look like 7 6 5. Okay, and the reverse is n minus k to n minus 1. Now we have two arrays which are reversed. Finally we need to reverse the third array. So reverse third array, the method will n minus 1. So we will reverse the array 5 6 7 1 2 3 4, and this is our final answer. This will take the time complexity of O(n) and the space complexity of O(1). Now let's check the code. So we have this rotate method, rotate method where we will get integer array and k steps. Okay, so first we will take the length, so integer n equals to array dot length, and the next most important thing is to calculate the k. So k will be k percent n. So why this? Because our k steps can be like 10, so it means the rotate the array 10 times. So if we rotate the array with n elements, then we will get the same array. So that's why we need to use formula, we need to use the k mod n, so we can iterate the array, rotate the array k times, and so this will return 3, and we need to rotate the array 3 times. Then we need to reverse the first array, an array, and then 0 to k n minus k minus 1. The first array. The second array is reverse array n minus k to n minus 1. And the third is reverse array 0 to n minus 1. And this is simple our code. Let's implement the reverse method. So what reverse method does, it will accept an integer array and the indexes, the index L and index R. So while L is less than R, the left pointer is less than R. First we need to use the temp variable where we will store the array of left element. Then array of L equals to array of R, and then array of R equals to array of temp. Sorry, this is temp. Okay, and plus plus and then R minus minus, and that is the reverse. Thank you.